All right, we're going to work problem 1 together right now, but here's a little bit of a hint that's going to help us as we work through this. So when we're trying to calculate the height, remember that a parabola is symmetric. So the maximum height is going to be the vertex, and that vertex always happens halfway through the path of the parabola. And so instead of using the whole time, like let's say 10 seconds, we could use 5 instead, because that's going to allow us to kind of manipulate the equation to make it a little bit simpler. And so here's how that would work. So for example, let's suppose that an object was in the air for 10 seconds. So if we were going to use 10 seconds, then that would mean that we are going to start at 0, and we'd have to figure out what our initial velocity was there as the object was launched. Okay, so it's going to be launched and then come back down and then land, and that's going to be a total of 10 seconds. And we may or may not know this initial velocity that started over here. And even if we don't, or even if we do, it may not be the most friendly number for our calculations. It'll work just fine. But what we can do instead is, and we've talked about this when we've talked about increasing and decreasing, the path of the object is going to be increasing as we go up, decreasing as we go down. But remember, we've talked about at this point here at the top, it's neither increasing nor decreasing. It's not really doing anything. So at that moment, that split second that it's hovering in the middle, our vertical velocity would be 0. It's neither increasing nor decreasing, so it's not moving at all. It has no velocity there. And so what that allows us to do is, instead of having to know that initial velocity, if I want to look at the whole time over 10 seconds, maybe let's instead start with the time halfway through, which would be right here at t equals 5, because at that moment we know that our vertical velocity is 0, and we love any time that we can plug 0 into an equation. So then for those 5 seconds, we would be really calculating just this path here, and that would be enough to help us figure out what this height is right here without having to use both sides of the parabola. And so if you look at the example that they've got over here, like we said, it allows us to set that initial velocity equal to 0, because at that moment it's suspended in midair with no velocity, and the initial position that we want to consider we could use as 0, and so that is going to allow us to calculate the difference between, we're considering this moment right here sort of as 0 and moving over to the edge for the time for 5 seconds. So that allows us to take this equation right here, and if this is 0, this is going to 0 out. If Vy initial is 0, this is going to 0 out. And so really this piece of the equation is the only thing we have to work with, which is what they've plugged in here. And so you can quickly calculate a distance of negative 122.65 meters. Now, a negative distance doesn't really make sense. However, in this case, we are looking at this as directional. So when we say that the distance is negative, that's telling us that the distance, it's moving down a distance of 122.65 meters. And so a negative answer here does allow us for a little bit more interpretation than what we normally get with our equations. So let's look at our first example. Oops. Okay. Here we go. A baseball player makes a throw that travels 200 feet through the air. The ball was in the air for 2.1 seconds. For this and similar problems, assume that the initial position horizontally is x and the initial position vertically is 0. Sorry, they're both 0. So what was the horizontal velocity of the throw? Now, before we start, let's make sure that we gather all of our information here on the side. They've given us a nice little table to help us fill out the things that we know and organize our thoughts a little bit. So what are the things that we know with our units? So a baseball player makes a throw that travels 200 feet. So 200 feet, that's our total horizontal distance. And so that is x. So we know that x is equal to 200 feet. The ball was in the air for 2.1 seconds. So that told us time. So that would be t, 2.1 seconds. And then they've told us to use that x initial is 0 and y initial is 0. And that's really all that we've been given. So that's what we've got to work with. Anything else we would need to either calculate or figure out some other way. So first question, what was the horizontal velocity of the throw? And they've given us a hint of which equation to use. X is equal to the horizontal velocity times time plus the initial position. So that's what we're going to use. Now, think about what we've got here. Let's look at our variables and collect what we had. We need x. That was actually a piece that we were given. So we're going to plug that in. Vx, we don't know. T, we do know, that is 2.1. So we're going to be able to plug that in. And x initial, we do know they told us to use as 0. So we can just plug those things in. So the equation that we get is 200 equals Vx times 2.1 plus 0. Now, don't forget this Vx, that is one variable. Like you won't separate those two things. Vx is the variable that you're looking at. That means horizontal velocity, velocity with respect to x. So this plus 0 doesn't really matter because it's just a 0. We need to divide by 2.1 on both sides. And when we do that, we get 95, my stylus needs to be replaced, sorry, 95.2 feet per second. Velocity is always measured in distance per time, so feet per second. Make sure on this project that you're using proper units on everything. And so that's it. That's telling us the horizontal velocity of the throw. So again, we're taking a ball and we're going to throw the ball. It's going to go up and it's going to come down. What we just figured out was just the horizontal velocity. It has nothing to do with the vertical effect. It's just how fast is it moving as I was to watch the ball go from left to right. How fast is it going? Okay, part B, when was the ball at its maximum height? Okay, so this is where we can use that trick that we just talked about a little bit. So when was the ball at its maximum height? We said the initial x and the initial y should both be 0. So that means we're starting here. We're going to throw the ball up and it's going to come down and we're going to land. That happens at t equals 2.1 seconds. So when was the ball at its maximum height? That's going to be the top right here. And remember, that's always going to be halfway through. That's the time that we are interested in. So all we have to do here is take 2.1 seconds and divide it by 2. And so that tells us that at 1.05 seconds, don't forget your units, that is when the ball was at its maximum height. So then C wants to know what was the maximum height. And this is a really good example of what I keep telling you. Anytime we say when or where, that's asking with regards to X. Anytime we want to know what that value is, that's asking with regards to Y. So if I want the maximum height of the throw, we need to figure out the vertical height, which is Y. So that's why we're going to be using this equation. Now, because we're going to use this little trick, we know that halfway through is where it hits its maximum height. We're going to use 1.05 for t, just like we did in the example we talked about at the beginning. So we're going to use that for t. We know that g is going to be the effect with gravity, and they told us that. I think they said 32.18, but we're just going to go ahead and use 32.2. That's plenty accurate. So that's what we've got for gravity. The Vy initial at that moment where the ball is at its maximum height, remember this is 0 because that's that moment where it's just hovering in the air, neither going up or down. and the initial horizontal or vertical distance is 0. So we can plug all of those things in. So we know that y is equal to 1/2 32.2. Oops. Should be negative 32.2. Times 1.05 squared plus 0 times 1.05 plus 0. And once again, that is 0, so those are really irrelevant. When we work this out, we get that our vertical distance is negative 17.75. And again, it makes sense because the height is going down. We're on the second half of the parabola. But when we answer our question, we don't want a negative distance because the maximum height is 17.75 feet. And so that is what we get. Okay?